Welcome back, everybody. So this is day 2 of optimization. Now, what is optimization? Optimization is basically just taking word problems and applying what we know about derivatives to those word problems. Basically that. Taking what we know about when the values of the functions are going to be the biggest and smallest, namely the derivatives, namely the critical points of the function, the zeros of the derivative, and finding how that relates to different functions. Okay? Like, for example, we did a problem about maximizing area, knowing things about the perimeter, but maximizing area. We did a problem about minimizing costs based on, minimizing cost of a can, based on its volume, knowing that it has to have 1 liter of volume. How do we minimize costs? Well, cost would be related to how much material you would need, so therefore I would need to minimize the surface area, right? So we've done these problems about maximizing or minimizing a certain value. Okay, let's go here. Let's do another one. Find the point at which the parabola y squared is equal to 2x that is closest to the point 1, 4. So now we're kind of taking a little bit more of an abstract look at things, and we're minimizing something based off of just an equation, right? What are we truly looking to minimize here? What are we truly looking to minimize? We have this parabola, y squared is equal to 2x. It's kind of like it's kind of like sitting on its side because y squared is equal to 2x. Good. We're trying to minimize distance. That's what we're trying to minimize, right? We're trying to get this to be as close as possible. Okay? We're trying to find, based on this parabola, this y squared is equal to 2x, the parabola sitting on its side, we're trying to find when it's closest to point 1, 4. So we're minimizing distance. That's what we're trying to minimize. That's a C. Oh, we're trying to minimize distance. Okay, so what is distance? Well, distance is equal to the square root of x2 minus x1 squared plus y2 minus y1 squared. Like, that's just the distance formula. There's a lot of problems in the homework set that you need to know how to do that, or you need to know that formula. Let's just throw back to algebra, the distance formula. Difference in the x's squared plus the difference in the y squared. So it's kind of like Pythagorean Theorem, right? D squared, the distance squared, is equal to the change in x squared, the leg of the right triangle, plus the other leg of the right triangle. Difference in the y squared. All right. Now, in general, this is what this thing looks like. I could go and graph it, but it looks like a parabola sitting on its side. That's why it's y squared is equal to 2x, not y is equal to 2x squared. If it was y is equal to 2x squared, it would be sitting upright. Since it's y squared is equal to 2x, it's over on its side. All right, now, and I know point 1, 4 is sitting somewhere out here. 1, 4. I know that it's not on that parabola, right? If I take the y value and I square it, I get 16. Is that really equal to 2 times 1? No, it's not on the parabola. So I want to figure out what the closest distance is. What point on that parabola is the closest to that coordinate 1, 4? Now, I know that the distance formula, if I plug in 1, 4, if I know that it's got to have 1, 4, within the distance formula, I can plug that 1 and 4 into the distance formula. So D is equal to the square root of, and now because I'm plugging in an x and a y value, I can remove the x2 and the x1. The only thing the x2 and the x1 are doing is noting that they're different. So I'm just going to say x minus the x value that we're looking at, 1 squared plus y minus 4. And I know that x and y value must be on the parabola y squared is equal to 2x. Now, the issue is that I've got a distance formula that contains 2 variables. So I need somehow to input in for either x or y another equation, right? But I know that y squared is equal to 2x, right? Think back to the, can problem. We were looking at minimizing the surface area, and we used the area formula to create a new equation to plug into the surface area formula. Same kind of thing is happening here. I've got the distance formula, which I'm trying to minimize, but I've got this formula for the parabola that it has to match up with this x and y that I can use to plug in. I know y squared is equal to 2x. So therefore, what I'm going to do is I'm just going to get this set equal to x, and I'm going to say y squared over 2, or 1/2 y squared, is equal to x. So now I've got another equation that's already solved for x. Could I have solved this for y? Of course. I could have said y is equal to the square root of 2x, but I'm not looking to find any derivatives on a square root right now. I'd rather do it on y squared, honestly. All right, so d is equal to, all right, we've got x is equal to 1/2 y squared. That's y. Everybody see what I did there? All I did was take y, 1/2 y squared, and plug it in for x. Now, I'm going to look to minimize the distance. Now, if I want to minimize the distance, I want to find the derivative of this, right? However, if I want to minimize this function, it's actually the same as minimizing that function. Okay? Minimizing the distance formula, minimizing this square root. If I square the opposite side, the smallest value of this is going to give us the smallest value of the square root of it, right? I hope we would all agree with that. Yeah.
Why is the y not squared anymore? Okay.
What are you talking about?
Okay.
What are you talking about? It's still squared.
Okay.
Minimizing the square root of that function will happen at the same place where I minimize what's underneath the square root. So it's actually going to help us a little bit. It's going to simplify things for us a little bit. I'd like you to use that same technique on your homework too. You could totally find the derivative of the square root function. That's totally fine. And it will end up at the exact same spot. But it's just a little bit easier if you just do that. All right. So let's find the derivative. Okay. Let's find the derivative of this piece. Okay. We good?
Well, how would you find the derivative of square?
It would have to be a big chain rule, because you would have to do this whole thing to the 1/2 power, right? And then so you'd have to bring out the 1/2 and then subtract it, so we put it into the denominator. Yeah, right? I think this is so much easier. Now, are we going to have to use the chain rule again? Of course. However, you know what we could do if we really wanted to? We could FOIL these things out and then find the derivative of them. But I got to be honest, it's easier if we just use the chain rule. Here's what I mean by that. We're going to take the derivative here by taking the 2 out front, 2 times 1/2 y squared minus 1, kicking down the power by 1, so bring it down. It'll be to the first power. And then I multiply by the derivative of the inside. What's the derivative of the inside? Be careful.
Y.
Just y. Because it would be 1/2 y squared. Bring the 2 up front. 1/2 times 2 is just 1. So it would just be y. Plus the derivative of the second piece. 2 times y minus 4. And then what would be the derivative of the inside? Just 1. I don't really need that, but just to show the chain rule, that's what that would be. I'm going to take off this power of 1 because it kind of looks like a prime almost. Bring flashbacks of implicit differentiation. All right. All right, now distributing the 2 and the y. This would be y to the third, would you stop that? Play nice. There we go. Y to the third minus 2y, right? I'm just distributing the 2 and the y at the same time.
Oh, okay.
Yeah. The 2 coming in takes away the coefficient minus 2, and then I got to bring in the y. Y to the third minus 2y. Plus 2y minus 8. Oh, and how fancy. So y to the third minus 8. All right, so that's, now this is kind of a weird notation. I'm going to say d squared prime, right? That's the derivative. So where am I going to have the smallest distance? Where this happens, right? It's the critical point of the derivative. It's the 0 of the derivative. Add the 8 over, take the cube root. Y equals 2. So what is x equals? Well, x equals 1/2 squared. Look, it's right up there. Still up in the corner of my screen. 1/2 y squared is equal to x. So 1/2 times 2 squared. So 2. So where is the closest point? 2, 2. That's the point that lies on that parabola that's closest to point 1, 4. Questions about that? And that's the only possibility of it being the minimum. That's the only, if I looked at y to the third minus 8, that's the only critical point, that 2, right? I could ensure that it was a minimum value. Like, I guess I'm thinking about it this way. This is a critical point. Could it possibly be a maximum value? I mean, I guess it could be. I'm just assuming that this is the minimum value. Should I really go in and see on a number line here? Here's 2. I should really go in and see that it's increasing and decreasing. Do the increase-decrease test. Like plug it back into the derivative. Something like maybe 1. 1 minus 8 would get us a negative. Something bigger. So 3. 27, that would be positive. Is it truly a minimum value? Yes. It's decreasing and then it goes to increasing. So we know for sure that it is a minimum value. I guess we should be a little bit more thorough with our work to show that it would indeed be a minimum value. And that minimum value would exist at 2, 2. Is that the only possibility of a minimum value within that function? Yes. How do we know that? Well, because of this increase-decrease test. The only place where the derivative equals 0 is at 2. So that's the only place where it's going to end up turning directions. Right? Because I was looking to minimize the distance. It's got to be the smallest value. What's that? I'd be looking for a maximum. And in this case, if I want to maximize distance, it would be infinite. I wouldn't find a location because I could keep going on forever and ever and ever, and each point beyond the next would be getting big, further and further away.
Why do you find the derivative?
What's that?
Like, I know that you use the derivative to find the y.
Well, how else would you find it?
I don't know why finding the derivative works.
Finding the derivative works because that's the only location where it's the smallest amount. The derivative actually tells you the critical point, which would be the only possibility of it being the smallest or biggest amount, based on what you're looking at. Shall we do another? Let's go for it.
I would not write that down.
That's okay. You did. Right. Exactly.
Yeah.
Okay, we got a guy launching his boat off of one side of a river. He's pushing off of one side of the river from point A. We're assuming that the river is straight, no bends. The river is 3 kilometers wide. He wants to get to a point B, 8 kilometers downstream, but on the opposite side of the river.
I close the door. Thank you.
Now, it says look at figure 7, but we're going to make our own figure. He could row his boat directly across the river to point C, and then run to point B if he'd like to. Or he could row directly to B and not run at all. Here's the issue, though. Or he could do some sort of in-between point. Point D, they're calling it. Row across to some place and then run the rest of the way. Here's the issue, though. He can row 6 kilometers per hour and run 8 kilometers per hour. So he can run and row at different rates. Okay? He can run faster than he can row. So, should he just row straight across, going slow, and then run the rest of the way? Or should he row the whole way there, because it's a shorter length, right? The distance would be less. Or should he find some point in between where he will row, then run? Let's draw it out, because some of you guys might not be able to visualize this. Here's my stream, as denoted by the waves. I'm at point A. Here's my boat. Here is point, what do we call that? Point B? No, he wants to get to point B. Here's point B. He could row directly across to point C. And we know that this is, I forgot to put this in, this is 3 kilometers wide. Yeah, we do know, well, it's 8 kilometers downstream on the opposite thing. So we're saying that that is 8 kilometers. Yeah, because if it's a slanted distance, that would be different. Because that would be the hypotenuse, right? Oh, yeah, we could have put it on the other side.
Denying the other side of the river.
That would be an issue. That would be an issue. Or he could go straight to B, or he could pick some point in between where he could row, then run. Okay. Let's also make note of the information, the important information here. Some point in between. We're not actually sure where that is along the 8 kilometers. We know that he can run 8 kilometers per hour, and he can row 6 kilometers per hour. What are we looking to do? Minimize time. Ooh, I gotta get here quick. Hold on one second. You want to set up shop right there? Okay. Set up shop. Get set over here. Oh, please.
What is no? I know, but like.
Yeah.
What's it? This class. I know it. What happened then? I know. How was your party? Doesn't it say that? You know how much money you make? Oh my God.
Wow.
That's great.
Yeah, I was really happy.
It was like, exactly, that girl that, and then like, perfect, yeah.
All right, here we go. Sorry. What are we looking to do? Minimize time. Right? That's what we're looking to minimize. Now, we know that time, right? Time is equal to distance divided by the rate. Because that's what we're playing with here, right? We're playing with how far we have to travel, and there are different rates that we are going on, right? That we are traveling by. We know that time is distance divided by rate. All right, so the time is actually equivalent to, and if I'm thinking about just the time in terms of going to D, right? Because I could calculate the time to get straight across the C. What would it be? What is the time going from A to C? 3 hours? Well, I'm going 3 kilometers. 3 kilometers and I'm rowing. 3 kilometers and I'm going 6. Wait, hold on. I'm going 3 kilometers and I could go 6 kilometers per hour. How long is that? 30 minutes. 30 minutes. Okay, just making sure. And what's the going from A to B? Be careful here. Don't we have to use the Pythagorean Theorem? Yeah, look, we got 3 squared and 8 squared. Let's figure out what that's going to be. 8 squared plus 3 squared. 8 squared plus 3 squared gets us 73. Let's square root that. 8.5. Well, there we go. 8.5 kilometers. Now, how long is that going to take us then? Oh, wait a sec. That's the wrong time for AC.
Yeah.
Well, that would be AC. But if I'm going straight from A to B, hold on, I got to fix that in a second. Right, that's just from A to C. Hold on a second. So if this is A to B, let's just finish this off. If this is just going from A to B, okay, just that, I have to travel 8.5, right? 8.5 is my distance, divided by my rate rowing is 6 kilometers per hour, 1.42 hours. Right? Okay, I kind of screwed up here. Not really. We just didn't finish it. I've got to go A to C, and then C to B. Right? I can't just row over to the other side and stop. I've got to row over to the other side and then run to B. So that's 0.5 of an hour plus, okay, I've got this is an hour.
Yes.
Yeah, this is 1 hour. Because I'm traveling 8 kilometers, running at 8 kilometers per hour. 1 hour. So 1.5 hours. So right away, do I want to row across then run? No. Right? So I know I can kind of throw out option 1. But maybe the combination. See, that's what we're looking at here. We're trying to find a combination of rowing and running that's going to minimize time. Because then we can see, is it smaller than these 2 options? If it's smaller than these 2 options, then I know that I'm going to do my combination. It's kind of like the closed interval method, right? Here's my option 1, here's my option 2, here are my 2 intervals, and I'm seeing if there's something that's smaller in between them. All right, so let's minimize time. Well, time is going to be equal to A to D traveling from A to D, than adding from D to B. Right? Well, look.
I mean, I get where you got it from, I'm just not, I would not be able to figure that out.
I think the drawing helps. I really do.
I would honestly
Find some place.
I would just stop.
So let's figure out the time. Let's go from, going from A to D? Okay, going from A to D. Well, that's A to D, the distance AD, divided by the time, or divided by the rate that it takes to, is that rowing or running? Rowing, divided by 6. Then let's take D to B. Well, D to B divided by what? 8. Okay, now I've got to come up with some sort of value that connects these things together. Okay? I've got to come up with some sort of value. What if we called this distance x? Oh, let's use a different color. What if we called that distance x?
What, C to D?
C to D. What would BD be equal to?
8 minus I.
8 minus x. Because I want to make this arbitrary. Yeah. Because I'm trying to minimize time, so I want to try to find. I don't want to make this some point in there. I want to try to find it so that it will be the best point. All right. Now, can we find AD in terms of x now? Yes, using Pythagorean. Look at this triangle in here. Do we see that right triangle? Where this is 3 and this is x. So that means that if I use those labels, that's going to be equal to, okay, we got to find AD here in a second. I do know DB. DB is 8 minus x. Let's figure out AD using Pythagorean. Well, that's x squared plus 3 squared equals AD squared. So the square root of x squared plus 9 is AD. What did you say, Christian? You can't take the square root. You can't take the square root of a sum like that. You can take the square root of a product like that, but not a sum. All right, so this is the function that we're trying to find the smallest value of. This weird square rooty type thing. That's what we're going to try to find the smallest value of. I am going to replace, I'm going to replace, instead of, oh, yeah. I could get common denominators here, but I'm going to replace this square root with an x squared plus 9 to the 1/2 power. Okay, and instead of writing divided by 6, I'm going to write it as 1/6 plus 1/8 times 8 minus x. Okay, Let's find the derivative. Let's bring the 1/2 down in front. 1/2 times 1/6. 1/12. To the negative 1/2. And then I find the derivative of the inside piece. This is a chain rule, to be 2x. Now, I could distribute that 1/8 in, but honestly, the only thing is going to be it's going to be 1/8 times the derivative of my inside piece. Well, what's the derivative of my inside piece? -1. So this is just going to end up being minus 1/8. Okay, let's fix this a little bit. Let's put all our stuff in the denominator where it needs to be. This is a 12 in the denominator, the square root of x squared plus 9 in the denominator, and then it looks like a 2x in the numerator. Yep. Okay. I'm going to reduce this down a little bit more with the 2 and the 12. It's going to give me x over 6 square root of x squared plus 9 minus 1/8. And that's my derivative. So let's see when it equals 0. Okay, let's see when it equals 0. So I'm going to have x over 6 square root of x squared plus 9 is equal to 1/8. I just add over the 1/8 over to the other side. Let's cross multiply because it looks like I've got a proportion. So it's going to be 8x is equal to 6 square root of x squared plus 9. And to get the square root to go out of the way, let's square everything. So 64x squared, 36 parentheses x squared plus 9. And let's solve that equation. No b term in here, which is nice. I can just solve directly. 64x squared is equal to 36x squared plus whatever 9 times 36 is. 324. Subtract the 36 over to the other side. 28x squared is equal to 324. Does that come out nice? 324 divided by 28. No, it definitely doesn't. 11.57. Then we square root it. Is that in my calculator here? That's so soon.
I thought it was pretty long.
3.4. All that just to see if it's possible that I would have a shorter distance going across.
We just find, so we basically just find
Oh. What did you say?
we just find from A to B.
We just found the x value. Just the x value. That's all we've done so far.
Yeah.
We need to actually calculate out how long it's going to take now. Now, how do we know how long it's going to take? Well, we plug it back into our time. Because time is equal to this function right here. Okay? So the time is going to be square root of x squared plus 9 over 6. Are you serious? Come on. Time is going to be equal to the square root of x squared plus 9 over 6. 8 minus x over 8. plus in between there, right? Yeah. So let's plug it in to find the time. I'm just going to use this 3.4. I have the square root of 3.4 squared plus 9 divided by 6 plus 8 minus 3.4 divided by 8. So let's see, 1.33. Time is 1.33 hours. Is that the shortest distance? Yes. Oh, sorry, I shouldn't say shortest distance. I should say smallest amount of time. That's the smallest amount of time that we should have, right? Because the other two possibilities, the other extremes I would have, the walking, just the rowing, is 1.5 and then 1.42 hours. So just by a little bit of time, 1.33 hours.
So it's weird that you know, like I think I just put 4 in.
That's a very good thing. Okay? Questions about that? We got one more problem.
I don't think we have.
Let's do that at the very beginning of class tomorrow.
Yeah.
That means the rest of tomorrow will be a work day. If you printed out your notes, like I know that you did, we are not doing the last 2 pages.
You skipped the notes too.
Right. I know. You don't have to go. That was a good problem.
That was.
I don't know if I give you something that involved on a quiz. That was pretty. That was a lot. But fun though. I mean, look at that diagram. Now that's excluding like the current of the river and like how much it's dragging you or pushing back. Add more, wind. Is the wind helping? Is the wind hurting? Is there a sail? Right? Did it say a sailboat? Just a boat.
Did you think
I drew a sail on there.
Truck and actually was much faster than one.
I know. What happens if he plants a bike on the other side?
What if you fall and like
Yeah.
sprain your ankle and you're only wobbling for one?
Right. Ooh. What happens if there's some point E where you are running and you sprain your ankle?
In what situation was that?
What
What if you were running at 12 kilometers per hour?
I know, really. What if after 5 kilometers you start to get tired and decrease?
What if your arms get tired while rowing?
Right, exactly.
Are you still moving because of the current?
If
current.
a tree falls, or doesn't so many different possibilities. I know.
Is it actually you registering what it is, or is it just the name?
See, that's what comes first, the chicken or the egg? Do you need a receiver of the sound for it to make a sound?
You need a solid definition of what sound is.
Is sound
And whether you actually believe that sound waves constitute sound.
right? Because technically, in my opinion, the brain is what makes the sound. Your brain interprets it as what we think of as sound. So without a brain to interpret it in that way, it's just a wave.
But if there was a mosquito or something and it happened to encounter it, would it then be a sound?
I would say yes.
Mosquito present?
But then,
But could mosquitoes
how do we know that
register a
mosquitoes
sound?
register sound like we do?
Well, even if they don't, it would still be a sound. It's not.
Do they have auditory?
Oh, that's a good point. That's what I was.
Do they have
Mr.
hearing?
Al?
Do they have an eardrum? Thank you for letting me strong. Yes.
I have a question.
Yes.
I look at that black Yeti every day.
It has not moved in a very long time.
I know, why is it there?
Because I forget probably how to wash it.
Oh my God.
It's
It's dirty.
I mean, it's empty. It's not like,
Pathetic.
there's not like.
Oh.
Should I bring it home and watch it?
Yes.
Okay, I'll put it next to my bag. Yeah, there's nothing in it.
There's dried liquid. I was just wondering. I look at it all the time.
Yeah. I got it.
Whoa! What's that?
Who doesn't have Monopoly?
I have Buckopoli and OSU Wapoly.
Oh, really?
Yeah.
Yeah.
Is your life? My parents is art. Yeah. No, my mom is.
Where did your dad graduate?
He's not here. That's embarrassing. He played basketball.
I am getting half of my dad.
Yeah.
That's just how he is.
Two, I think.
But you can.
Not well.
That's the thing.
People, it's getting warmer. It's, right now it's 30, let me check, let me refresh, 37 degrees right now. On Saturday, it's gonna get up to 50 degrees.
Oh, wow.
Break out the pool.
Wow. Honestly, that is like cool weather in Ohio.
I was just trying to do. What is Hartford Kitchen? Where did it come from? They just put it in.
Where?
That's the one that.
I don't think I like those. I got something in North Canada.
Is that great? Your hands one you.
It's a great.
And it's teas. Yeah.
Okay. I've
It's
never
like way
been.
too much.
The one I lost, no, I didn't because we had two black fishes
For kids.
somehow. So we restarted.
Our one nice restaurant is Grinders.
Well, sort of.
I'm like, we lost.
Oh wait, no,
Buddy
there's
doesn't
Carlos.
know where
Absolutely
it is.
disgusting.
Carlos, we have Carlos's?
What?
Yeah.
So good.
Yeah.
It's so good.
I was like,
It makes me just
I'm
want
not bad.
It's horrible.
I mean, we're still almost one.
I still think about that.
It looks shady, but.
Don't say anything though. I look at a trending. No, I just fell for it today. No, I swear, I just carried on. I didn't think of it. But then today she was drinking and she was like, yeah, Kristen. And then I was like, like, he
tomorrow.
And like I still put it in. I was there.
And a fizzy
He
check
came at
tomorrow.
like 8. I was there at 4:30. I really had nothing.
What do you do then?
That's why I was thinking, like, you were just, you couldn't really have.
Good girl.
Oh, because she said,
Are
what happened?
people born
Okay,
good or
just
bad?
like, why drive there?
Yeah, I know. I looked at my Google Docs and I found a paper I wrote on it. Bang, done.
But she said no, so what was your occupation?
Copy and paste my thesis.
Oh, how? I didn't know
You
you
should
guys
have
were,
looked at me.
I didn't know you guys were, why did you?
It's not me.
That was your first
No, she was the one that texted me first.
Oh, what
Grant's
was
born.
She screenshotted it. It said,
What you
it was like, you know how she
say yes or no? I said,
It's like,
I'm pretty sure I said no.
I was like, I am not grinding all this stuff.
Grant's born.
And then, for my life, I stayed at home and after you guys have a quiz. So it's only 2 videos long.
Why does it look so weird?
There wasn't a.
I don't know where.
No, but
There's no.
After today, I get the next 4
You have your red.
But I got more.
and
Saturday. To see what I'm
Wait, that is cool on your
I
part.
will not.
I know, I'm hyped.
You like
I was
that?
supposed to work Friday, but I came off because I couldn't get it.
Hey, have a great day, everyone.
You too.
Okay, how did they go on Friday?
Really cool.
Yeah.
Hey.
Yeah, so.
Any case,
But, yeah, and then, oh no, and then we're gonna do like 1,000 to like something into research, so it was way better than that. It was like, we were 28 minutes in and we were at max capacity, like I had to
Really?
sign out, and I was like, I'm so sorry, like, we can't come in.
Seriously.
Yeah, but they
What
didn't
is the
ask
problem
me.
to have? That's awesome.
Yeah, it was. How was your washer?
Honestly, we stayed in all the way.
It worked well. It was really Hey, that's good.
Thank you for asking.
Yeah, thank you for asking. Have a good day.
Oh, my video's still going. Oh, boy. My video's still going. I'm gonna have to edit this sucker. Oh, jeez.